You have exactly 20 minutes before your physics mock exam begins, and your grade is completely on the line. Your palms are sweating, you're frantically flipping through the syllabus, and deep down, you're wondering if you actually know how to secure those final, crucial marks. You know the formulas, sure, but do you know how to survive the examiner's traps? Because here's what usually happens. You sit down in the exam hall, calculate efficiency perfectly, write down 0.09, slap a joules unit on the end out of pure habit, and boom, you instantly lose the final marks because of a fatal, incredibly common trap. Efficiency has no units. It's a ratio. Adding joules right there proves to the examiner you don't actually understand the core concept. And this is exactly why ordinary revision fails. Memorizing equations just isn't enough if you don't understand the command words, or how to avoid disastrous early rounding errors. You need a strategy of minimum effort for maximum marks. That means understanding the mark scheme's psychology so you can deliver exactly what they want without wasting a single second.
Section 1, the Top Band Answer Framework.
Okay, let's dive into the elite strategy that reliably transforms ordinary answers into top band scores. This four-step framework is literally your secret weapon for any question on energy stores, transfers, and work. First, concept. Show you know the underlying physics law. Second, evidence or data. Pull this directly from the prompt. Third, scientific reasoning. Logically link the two together. And fourth, examiner wording. Hit these four steps and you are locked in for full marks without having to write out massive, unnecessary paragraphs. Section 2. The high-stakes exam truck. Now, what's really wild is how easily students throw away method marks when the stakes are high. You've done the hard part, right? You understand the physics, but then a tiny oversight ruins the entire calculation. These are the exact pitfalls examiners see over and over. Missing units at the end of a long calculation, rounding midway through your math, and drawing conclusions that are completely unsupported by the data. These are the silly errors that turn an A-star knowledge base into a B-grade result.
So the absolutely crucial point here is swapping those weak mistakes for these highly specific exam-safe corrections. Instead of rounding mid-calculation, keep the exact values in your calculator until the very final answer. Instead of giving efficiency a unit, remember it has no units, or just use a percentage. And please, instead of writing a vague phrase like heat lost, you must strictly specify thermal energy dissipated to the surroundings. It's all about training yourself to use the exact vocabulary the mark scheme demands.
In a moment, I'll show you the exact examiner clue that changes the answer completely. But first, you need the framework that makes that clue obvious. Let's say if you've developed an examiner's eye. Can you spot the trap in this classic conservation of energy calculation?
Pause and predict the error on the left before I reveal the top band correction on the right. Spotted it? Look closely at the mass. The flawed answer plugs 500 directly into the kinetic energy equation, but that 500 is in grams. The improved top band answer instantly converts that 500 grams into 0.5 kilograms before doing any math, giving the correct answer of 36 joules.
And this brilliantly illustrates why examiner feedback reports say the same thing year after year. Always convert mass from grams to kilograms before using equations to ensure consistent SI units. Checking your variables against standard units is simply non-negotiable if you want full marks. Section 3, Energy Conservation Exam Challenge. Let's level up to a harder example and see how this framework builds your marks. Exam papers love combining different energy stores to test your fundamental understanding. Before you calculate a single thing, you must state this key law perfectly using correct physics terminology. Energy cannot be created or destroyed. It can only be transferred between stores. Lock this definition in your memory before you tackle complex scenarios like a swinging pendulum. Just look at how energy transfers perfectly between stores in a swinging pendulum. At maximum height, gravitational potential energy is at its maximum, while kinetic energy is essentially zero. As it falls to its lowest point, all that potential energy converts, meaning kinetic energy is now maxed out. The vital takeaway here is that total energy remains constant throughout the entire swing, assuming zero air resistance. But here's the catch. While theoretical models assume 100% efficiency, real-world practicals never actually hit this number. Energy is always transferred to the thermal store of the surroundings. Which brings us to your final and honestly often the most difficult exam hurdle.
Section 4. Avoiding common practical errors.
All right, here is that practical evaluation clue I promised you earlier. When you face an alternative to practical question asking how to improve an experiment, do not panic and write reduce human error. No way. Use these 2 steps to lock in the method marks. Step 1. Identify the specific energy loss, like thermal energy dissipating to the bench. Step 2. State a precise apparatus improvement, such as adding lagging or insulation to the beaker.
Also, ensure your final conclusions are strictly supported by your data table or graph scale. Examiners actively hunt to penalize answers that just guess the outcome based on theory, instead of referencing the specific evidence you just calculated. Simply put, if your graph line doesn't prove it, don't write it.
Section 5. Your next mock survival step. Okay, you now have the ultimate framework to dominant energy stores, work, and power calculations. You know the unit traps, the terminology, and the practical evaluations. But there's one massive obstacle left. How do you secure full marks when the exam suddenly demands you apply these exact rules to a complex, multivariable data analysis graph? Your mock survival plan isn't complete until you know how to extract the right data points without falling for the axis scale traps that eliminate half the candidates.
You need to know how to read those graphs perfectly. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations and jump straight into the next explainer right now on your screen to master that exact data analysis skill before your mock begins. If you can't prove your theory with the data in front of you, do you really know the physics at all? Click the video on screen and I'll see you there.